Reified type parameters, accessing type information at runtime. In Kotlin, generics normally suffer from type erasure, meaning type information is lost at runtime. However, Kotlin provides a powerful feature called reified type parameters that allows us to preserve and access type information even after compilation. This opens up possibilities that aren't available with regular generic functions. Let's first understand the problem we're trying to solve. When you create a generic function with a type parameter t, you cannot access t's class information at runtime. For example, if you try to write a function print type that takes a generic type t and attempts to print t::: class, the compiler will give you an error. This is because generic type information is erased during compilation, a concept known as type erasure. The type parameter t simply doesn't exist at runtime. The solution to this problem is combining two Kotlin keywords, inline and reified. By marking a function as inline and the type parameter as reified, we can preserve the type information at runtime. Now, the same function print type works perfectly. We can access t::: class without any issues. The key difference is those two keywords working together to make the type information available at runtime. But how does this actually work? When you mark a function as inline, the compiler doesn't generate a normal function call. Instead, it copies the function's bytecode directly to every call site. So when you write print type with the type argument string, the compiler replaces that call with the actual body of the function. But with strings substituted for t, this means the compiled code directly contains println string : class, with the concrete type baked in. This is why type information is preserved. Let's look at a practical example. We can create a function called isType that checks if a value is of a specific type. The function takes any value and returns a Boolean indicating whether that value is of type t because t is reified. We can use the is operator to check the type at runtime. When we call isType with string as the type argument and pass the string hello, it returns true. But if we call isType with int and pass hello, it returns false. This wouldn't be possible without reified type parameters. Here's another useful example, filtering collections by type. We can create an extension function on list of any called filter by type that returns only elements of a specific type. Internally, it uses Kotlin's built-in filterAsInstance function, which also requires a reified type parameter. In the usage example, we have a mixed list containing strings and integers. By calling filter by type with string as the type argument, we get back only the string elements a and b, the integers are filtered out. This is extremely useful when working with heterogeneous collections. There are three key requirements to remember when using reified type parameters. First, the function must be marked with the inline keyword. Second, the type parameter must be marked with the reified keyword. And third, both keywords are required together. You cannot use reified without inline, and inline by itself doesn't give you access to type information. They work as a pair to enable runtime type access. Reified type parameters are commonly used in several scenarios. First, type checking and casting operations, as we've seen. Second, JSON parsing and serialization libraries like JSON and Kotlin serialization use reified types to determine which class to deserialize data into. Third, dependency injection frameworks use them to resolve dependencies based on type information. And fourth, generic collection operations like filtering and mapping by type. Understanding reified type parameters is essential for writing type-safe, flexible Kotlin code, and for using many popular Kotlin libraries effectively.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.